first step?
How do you do that?
Right. Before you write your matrix, you need the constants on the other side of the equal sign. So, my matrix would be 3, 5, -5, -2, 3, 16. Okay, we need to do what first? Always. You get the 1 in row 1, column 1. More than one way to do that. When in doubt, if you can't come up with anything else, you can always multiply by a reciprocal, and that will give you a 1. That will give me some fractions here, but that is doable. Is there another option for getting the 1?
Row 1 plus row 1.
So row 1 equals row 1 plus row 2. Okay, so 3 plus -2 is 1. 5 plus 3 is 8. -5 plus 16 is 11. And we did not change row 2. Okay, we get the 1, then we need the 0. So we need row 2, column 1 to be a 0.
So 2 equals row 2 plus 2 on.
Kind of the standard that I gave you. Row 2 equals row 2, it's a -2, so we need to add 2, but you can't just add a number, so it always has to be times another row. So times the row with a 1 in that position. So -2 plus 2 is 0. 3 plus 16 is 19. 2 times row 1.
Oh, 2 times.
16 plus 22 be 38. If anybody's lost, there's different ways to write this. A lot of times I suggest if you're confused using your calculator here. Essentially for each entry I did row 2, so the first one was -2 plus 2 times the number in row 1. That gave me the 0. Next one we had row 2, which was a 3, plus 2 times the number in row 1, which was an 8. And that's where I got my 19. Next one we had 16 plus 2 times the 11, which gave me the 38. You can also, write out the rows, take the first row times 2, write the 1 underneath it, and add them together. So the work is kind of up to you what you need to see. You guys okay with that? How that looking good? So, column 1 is good. We got the 1, then we got the 0. Next we go to row 2, column 2, and we need this to be a 1. So we've talked about different ways to get 1. When in doubt, multiply by the reciprocal. So 1 over 19 times row 2. And that will always work to give you a 1. So 1 over 19 times 0 is still 0. 1 over 19 times 19 is 1. 1 over 19 times 38 is 2. Now we need everything else in this column to be a 0. So I need to change row 1, start with row 1. It's a positive 8, so subtract 8 of row 2. So again, if you need to show work, do that. Row 1 minus 8 times the number in row 2. So that's a 1. Row 1 is 8 minus 8 times 1 is 0. 11 minus 8 times 2 is -5. And then we write our equations, x is -5 and y is 2. Is that okay? Let's do one with 3 equations. We'll do a couple like this. We'll start off with an easy one and then do a harder one. All right. So if we set up our matrix, what's the first one?
Oh, that's fine.
Okay. So if I actually write the matrix, we have 1, 1, 1, vertical bar, 1. Next one, -1, 1, 1, 5, and 0, 1, 2, 5. So we need a 1 in row 1, column 1, but it's already there. So we can go ahead and go to the next step, which is zeros everywhere else in the column. Now the bottom one's already a 0, so I don't even have to worry about it. The only thing we really have to change is this one right here.
So we can add the 1
So row 2 would equal row 2 plus row 1. So rows 1 and 3 are not changing right now. And to get row 2, you add rows 1 and 2. So 1 plus -1 is 0. 1 plus 1 is 2. 1 plus 1 is 2. 1 plus 5 is 6. Alright. Next, we need a 1 in row 2, column 2. So you don't want to do row 2 minus row 1 because that will undo this 0, but could I do row 2 minus row 3?
Yeah.
That would give it to me. What's another way?
It's just flip it.
You could just flip rows 2 and 3, and that would give it to me. What's one more way? Multiply by the reciprocal. If I multiply by a half, it's not even that bad because I won't get any fractions. So 3 possibilities, any of them will work. Okay, let's flip. So let's just say row 2 will equal row 3. I'm just going to flip rows 2 and 3. So I have my 1 there. Now I need everything else in that column to be 0. And I told you yesterday, this is the one thing that you can do at the same time. So we can change row 1 and row 3 at the same time here. We're not messing with row 2. Okay. Row 1 equals row 1. It's a positive 1, so we need to subtract what? Row 2. So if I do that, 1 minus 0 is still 1. 1 minus 1 is 0. 1 minus 2 is -1. 1 minus 5 is -4. row 3 equals row 3. It is a positive 2, so I need to subtract 2 of row 2. So 0 minus 0 is still 0. 2 minus 2 is 0. 2 minus 4 is negative 2. 6 minus 10 is negative 4. Everybody with me here? Especially those that weren't here yesterday, because we kind of started doing a little more with these yesterday. If I lose you, tell me, okay? Alright. Now we have to go row 3, column 3. And I need that to be 1. What's the easiest way to get that to be a 1? Multiply by the reciprocal. So I'm going to take negative 1/2 times everything in that row. And 0 times a negative 1/2 is still 0. Negative 2 times negative 1/2 is 1. Negative 4 times negative 1/2 is positive 2. We have to do one more. We need everything else in column 3 to be a 0. So we can do both of these at once. Row 1 equals row 1. It is a negative 1, so we have to add row 3 to that.
How do you know which way to add?
Basically, we just got a 1 in row 3, so I'm going to be adding multiples of row 3. We don't want to add the others because that will undo the zeros that we have. So whatever row you just got done getting a 1 on, that's the one you want to add. Alright, so 1 plus 0 is still 1. 0 plus 0 is still 0. Negative 1 plus 1 is 0. Negative 4 plus 2 is negative 2. Row 2 equals row 2. It is a positive 2, so we need to subtract 2 of row 3. So 0 minus 0 is still 0. 1 minus 0 is 1. 2 minus 2 is 0. 5 minus 4 is 1. Then we get x is negative 2, y is 1, and z is 2. So adding that third equation does add quite a bit of work to it. But remember it did when we did substitution and elimination too. When we had that third equation, then we had a lot more steps involved in our problem. Okay. What do you think? Do we need to do one more?
Yeah.
Huh?
Oh, yeah.
Yeah. Let's do one more together, and then I will give you your homework so you can do them on your own and ask questions. How about that? That way everybody can kind of get whatever help they need, because I know we're all at different spots here. All right. What do we want? Easy, hard? Easy. Oh, that is no fun. Moderately hard? start by writing our matrix. You'll notice we don't have a y, so we have to put a 0 for the y. What's the first step? 1 in row 1, column 1. Okay, lots of ways to get that. You could multiply by a fourth. You could do row 1 minus 3 of row 2. You could do row 1 plus 3 of row 3. Or we could just flip rows 1 and 2. Because we notice row 2 already has a 1 there. So that is probably the easiest option, just to flip 2 rows. So we just say row 1 equals row 2. Now we need everything else in that column to be 0. So row 1, that's the one we just got a 1 in that position, so that's the row we will be adding or subtracting to these. So for row 2 equals row 2. It's a positive 4, so subtract 4 of row 1. So if I went ahead and did that, 4 minus 4, 0. 2 minus negative, so 2 plus 16, I mean 18. Negative 3 minus 4 is negative 7. 6 plus 16 is 22. We could also go ahead and change row 3 here. So row 3 equals a row 3. It is a negative 1, so we just have to add 1 of row 1. So negative 1 plus 1 is 0. 0 plus negative 4. Negative 4. 2 plus 1 is 3. 2 plus negative 4 is negative 2. Alright. Made a nice pretty one here for you. So we need a 1 in row 2, column 2. Okay, if you don't see any other options, you could always multiply by the reciprocal. So 0 times 1 over 18 is still 0. 18 times 1 over 18 is 1. And 7 over 18. 22 over 18 would be 11 over 9. Now what do I need? Zeros for both of these. So you could do like row 1 minus row 3 for this first one, but that wouldn't work for row 3 because that would undo your 0. So that is an option for the first row anyway. So we could do, if we do it like that, our kind of standard, you could do row 1 minus row 3 and that would work, or you could do row 1 plus 4 of row 2 because we just got our 1 in row 2. Row 3 then would be row 3, it's a negative 4, so plus 4 of row 2 as well. Alright. So row 2 is not changing. This might be a good one to pick up your calculator and kind of use it to help you along. you have 1 plus 4 times 0, which is still 1. Negative 4 plus 4 times 1, which is 0. 1 plus 4 times negative 7 over 18. Keep it in a fraction, it should be negative 5 over 9. Negative 4 plus 4 times 11 over 9. And that gives me 8 over 9. Row 3. 0 plus 4 times 0 is still 0. Negative 4 plus 4 times 1 is 0. 3 plus 4 times negative 7 over 18, 13 over 9. Negative 2 plus 4 times 11 over 9 is 26 over 9. Alright, first 2 columns are done. We have 1 column remaining, so we are getting close, 2 steps away. I need to get a 1 here. So how would I change 13 over 9 into 1? 9 over 13 times row 3. I should probably point out, all the problems we've done have nice answers at the end, and I'm going to continue that. I'm going to give you ones that have nice answers, but in general, they don't have to. There's nothing wrong with getting a fraction for a final answer. I'm just giving you nicer problems to practice this. So 0 times anything is still 0. 13 over 9 times 9 over 13 is 1. 26 over 9 times 9 over 13 is 2. Last matrix, we need both of those things to be 0. So row 1 equals row 1. It's a negative 5 over 9, so plus 5 over 9 times row 3. For row 2 equals row 2, it's a negative 7 over 18, so plus 7 over 18 times row 3. Row 3 did not change. 1 plus 5 over 9 times 0 is still 1. 0 plus 5 over 9 times 0 is still 0. Negative 5 over 9 plus 5 over 9 is 0. 8 over 9 plus 5 over 9 times 2 is 2. 2. 0 plus 0 is still 0. 1 plus 0 is 1. Negative 7 over 18, positive 7 over 18 is 0. 11 over 9 plus 7 over 18 times 2 is 2. X is 2, Y is 2, Z is 2 on this one. Okay, so the rest of the hour, you have time to work on these and ask questions. Just kind of a recap to make sure you've got everything, page 518. Remember the first day I gave you 2, 4, 8, and 12. Yesterday I added 16, 18, and 22. Today I want to add problems 20, 28, and 30.